A second example of being able to determine where a function is increasing and where a function is decreasing, this time using a transcendental function, we have negative x squared plus 2 natural log of x. Same steps as before. First, let's find the critical values for f prime. Now, f prime of x is really easy to find. Negative 2x plus 2 over x. And remember, we're going to set that equal to 0. Next thing we're going to do is we're going to solve. So let's add 2x to both sides. So we get 2 over x is going to be equal to 2x. We can multiply both sides by x. And so we get 2 equals 2x squared. We can divide by 2. So that means 1 is equal to x squared. And then the two critical values are going to be plus or minus 1 for x. Now, unfortunately for this problem, we have to be really careful because isn't it true that there's a domain restriction, right? And also notice that x equals 0 is critical since f prime at 0 is undefined, all right? So we have to be really careful in remembering those conditions for critical values, all right? The domain of the original function is x bigger than 0. And so that's going to help us because when we go to construct our sign chart, that means that we do not need to worry about x equals -1 since x equals -1 is not in the original value or the original domain. Okay, so what are the critical values really? Well, the critical values really are going to be x equals 0 and +1. And again, -1 is not in the domain of f. All right, so we be careful with that. Second thing we're going to do, we're going to make a sign chart. Okay, and this time, when we make the sign chart, we have our two critical values. So remember, we have 0 as one of our critical values and 1. And we don't have to worry about anything to the left of 0. Okay, because remember, the domain of f is such that x is bigger than 0. All right, so, and realistically, we have an open circle at 0 anyway, because we know that the natural log of 0 does not exist. And so what are some good test values then? Well, one good test value might be 1/2 or 0.5, and another one might be 2. And all we're going to do is we're going to stick 0.5 into the first derivative, and we're going to stick 2 into the second derivative. And then we're going to see what happens to determine these intervals. Now remember, our derivative is -2x plus 2 over x. So this is going to be -2, 0.5 plus 2 over 0.5. Now that should be equal to 3, but let's verify that using our calculator. All right, so we go back, and clear this out. So we have 2, or -2, excuse me, times 0.5, I'll just say 0.5, plus 2 over 0.5, right? And that indeed works out to +3. And I can't stress enough that we really don't care about the sign, or I'm sorry, we don't care about the number, we really care about the sign, whether it's greater than 0 or less than 0. Because it's greater than 0, this function is going to be increasing for all values between 0 and 1. Now, what about 2? Well, that's going to be -2 times 2 plus 2 divided by 2. And that's going to be -4 plus 1, which is -3, which is clearly less than 0. And that means that this function is going to be decreasing, right? So, and remember, this goes all the way out to +infinity. So there's only two intervals that we have to worry about. So this function is increasing on the interval from 0 to 1, and it's decreasing on the interval from 1 to infinity. The ultimate tell is to graph the original function. So let's go back and graph the function, and let's see if at 1 it increases till 1 and then it decreases forever after that. So remember our function, negative x squared plus, I believe it was 2 ln of x, but I just want to verify, plus 2 ln of x. And we're going to graph. Now I'm going to zoom standard. All right. And notice right here, all right, so this is what our function looks like. There's nothing to the left of this graph, and that's good because we didn't say it was doing anything. And it looks like it's increasing until we get to about 1. In fact, we can zoom in. So let's zoom in. And I'm going to move the cursor so we can zoom in right around the point at which we change. All right. And then we can do a trace. All right. So now check this out. Keep an eye on the y value. So the y value is getting bigger, okay, as x gets closer to 1. So now we have negative 1.003. And well, let's go a little bit further over here. So we have negative 1.08, and now it's getting bigger at negative 1.04 and negative 1.01. And then finally, it's almost at negative 1 right here when x is 1 almost. But what happens when x starts to get a little bigger? Okay, so now it's negative 1 almost, and then it's going to start going down. And that's what we expect, at least from our calculus. Right? So now this might be difficult to discern from the graph. And that's why we always want to use the graph as a guide, but we never want to trust the graph without going through and doing our calculus. All right, so hopefully these are two good examples as to illustrate where a function is increasing and where a function is decreasing. In the next two videos, we're going to take a look at how to determine the concavity of a graph and the intervals for which it's concave up and the intervals for which is concave down.